So here is the Python coding for the first question. Firstly, we have to import the library pulp as P, and then I have to name the problem and also specify the goal, which is in this case, I name the problem as problem 1, and also the goal for this problem is to maximize the quantity of the chair. And then I have to define the variable and also its sign restrictions, which is in this case x as the quantity of tx model chair and y as the quantity of gx model chair, where the where its low bound is equals to 0. And then I have to define the objective function, which is in this case maximum z is equal to 50x plus 60y. Then after define the objective function, we also have to list all the constraints that we have formulated just now, which is in this case we have three constraints, which is the first constraint 6x plus 10y less than equals to 180. And then the second constraint is 2x plus 4y less than equals to 200. And the third constraint is the 4x plus 4y less than equals to 100. And then I want to display the formulation of the LP. So I use the print command and print the LP prop. And then lastly, I use the solve and display command in order to solve the LP problems and also display the results. So here is the output for the first question, and based on the Python, the output will display the name of the problem, which is in this case problem 1, and also its goal, which is to maximize the quantity of model chair. And then um, since I have used the print lp prop command just now, so it will display the objective function and also the constraints. And then it will also display the variables, which is xy, and it is stated here that it is continuous since I have stated that the low bound is equals to 0. And then lastly, since I have used the print and also solve command, so it will display the optimal solution for this question, which is the value of x, y, and z. So for problem 1, the x value is 17.5, and then the y value is 7.5. And lastly, the optimal solution for z is 1325.
Okay, now we proceed to the next question, which is question 2. For analyze the question, we get the convert to the mathematical solution, which is I assume that we're going to using the P1, Y1, P2, and Y2 by converting from the potato and yam from the farm 1 and farm 2. So as summarized, the question is uh, the question is to find the minimum of the cost, which is for the convert to 90 P1 to plus 100 Y1 plus 80 P2 and plus 120 Y2, which at the same time the constraint we get, which is P1 and plus Y1 less than 100, P2 plus Y2 less than 100, 400 P1 and plus 350 P2 greater or equal 11,000, 500 Y1 plus 65, 650 Y2 greater than 7,000, which is P1, Y1, P2, and Y2 is greater than 0. So by using the SS solver, we get the objective, which is minimum cost, is RM 3,767 ringgit and 31 cent by using the converting from the Y1, Y2, P2, and P1. The next is by using the Python coding, which is we converting from the Excel to the coding style in the Python. So this is the coding we use. And the optimal solution we found by using the Python is equal to the Excel solver, which therefore the solution is same and equal. So that's all for question 2.
For the question 3, we have minimum W equal to 2x plus 4y plus 5z plus 3q. For the constraint, we have three constraints, which is negative x minus 2y plus 2z more than or equal to 40, 3x plus 2z plus q less than or equal to 100, and x minus 2y minus z plus 4q more than or equal to 50. For x, y, z, and q is more than or equal to 0. Okay, so I will explain question 3. Today, I will walk through a linear programming optimization problem solved using Python pub library. We will examine each line of code and understand how it contributes to finding the optimal solution. So for the first one, the import the library library pub SP. First, we attempt to import the pub library with an unconventional syntax. This library is our toolbox for linear programming. So the next line is we install the pub, which is pip install pub. This command outline shows how we would install pub if needed. The correct command is pip install pub, which we have already run as shown in our output. So the next line is import pub sp. Here we properly import the pub library, giving it the alias p for convenience. This given us the access to all of pub linear programming capabilities. The next line code is LP problem equal to PLP problem problem 3 PLP minimize. We get our problem instance called problem 3. The second argument P dot LP minimize specifies that this is a minimization problem that we are trying to find the lowest possible value of our objective function. So the next line is we define our four variable x, y, z, and q. The low bound equal to 0 parameter enforce that this variable cannot be negative, which is a common requirement in linear programming problems. So the next line is LP problem. I state the objective function that we want to minimize. The coefficient represent the cost associated with each variable. For example, variable z has the highest coefficient 5, making it the most expensive contributor to our objective. Now we add our three constraints. The first constraint requires that negative x minus 2y plus 2z must be at least 40. The second limit, 3x plus 2z plus q to no more than 100. Then the third one is require x minus 2y minus z plus 4q to be at least 50. This represents the boundaries of our feasible region. Next, the code print problem formulation. Before solving, we print out the problem formulation to verify everything is set out correctly. This is good practice to catch any potential error in our setup. Next, the print LP problem. This display the complete problem structure as pub understand it, showing our objective, function, and all constraint is standardized format in a standardized format. So next line is status go to LP problem solved. Here's why The solve method send our problem to the solver. PUB will automatically use the best available solver it can find on our system. Then next one is the code print solution status. After solving, we check the status in our output. We see optimal, meaning the solver successfully found the best possible solution that satisfies all constraints. The next line is we reveal our optimum value, which is x and y are both zero, meaning they don't contribute to our optimal solution. Then z is 20 and q is 17.5. These are our active variables. Then we notice how the solver has avoided using the most expensive variable where possible. Uh, Next line, finally, we print our minimized objectives value of 152.5. There is actually a small syntax error here. The f should be inside the parentheses for the f string to work properly. Then looking for our output, the solver confirm that this is an optimal solution exists. The variable x and y are zero because including them would increase our objective value. That one is the constraints are all satisfied exactly at their boundaries. The last one is our minimal cost is 152.5 units. So that's all for me.
So, saya nama saya binti Samsudin. Saya akan present soalan nombor 4, which is soalan ini adalah mengenai adding constraint. So, seperti yang kita lihat di slide, 4A, dia bagi kita find the optimal solution of the following LP. And then soalan B, find the optimal solution if we add constraint 3x1 plus x2 less than equal 10. C, find the optimal solution if we add constraint x1 minus x2 bigger than equal 6. And for soalan 4D, find the optimal solution if we add constraint 8x1 plus x2 less than equal 12. So, saya akan present macam mana saya selesaikan soalan adding constraint menggunakan Excel solve. So, untuk soalan 4A, seperti yang kita boleh lihat dalam slide, X1, X2 dan Z di sini merujuk kepada variable yang digunakan. Kemudian kita ada row solution, which is yang warna biru ni adalah solution untuk X1 dan X2, dan yang warna oranye ni adalah optimal solution Z. Dan kita juga ada row objective function 6 dan 1. Kemudian constraint yang diberi untuk soalan 4A adalah S1 plus X2 less than equal 5. And constraint yang kedua adalah 2x1 plus 1 less than equal 6. So, selepas kita masukkan value ni dalam Excel solver dan kita minta solver untuk selesaikan, dan solver result yang kita dapat, dia found a solution. So, which mean dia feasible lah. So, untuk jawapan 4A, kita dapat x1 3, x2 0 dan z equal to 80. So, kita teruskan dengan soalan 4B, which is adding constraint yang kita boleh lihat C3 berwarna pink ni. Yang mana adding constraint yang diberi adalah 3x1 plus x2 less than equal 10. Dan result yang kita dapat adalah sama seperti jawapan 4A, which is x1 3, x2 0 dan optimal solution Z dia adalah 18. So, bermaksud soalan 4B adalah feasible. So, kita teruskan dengan soalan 4C, which is soalan 4C di constraint 4, which is soalan asal dia adalah x1 minus x2 greater than equal 6. But, kita punya objective function adalah maximize. So, kita kena tukarkan kepada maksimum. So, bila kita tukar, kita masukkan terus value negatif 1. 1 less than equal negative 6. Dan solver result yang kita dapat dekat sini menunjukkan yang untuk soalan 4C adalah infeasible. Maksudnya tak ada optimal solution lah. Dan kita teruskan dengan soalan 4D, which is soalan 4 ni kita boleh tengok adding constraint dekat C5, which is dia punya adding constraint adalah 8x1 plus x2 less than equal 12. Tapi bila kita tengok solver result, since kita punya soalan 4C tadi adalah infeasible, jadi bila kita teruskan kita tetap akan dapat infeasible. So sepatutnya kita boleh berhenti pada soalan 4C lah. Sebab 4C dah menunjukkan dia infeasible. So kalau kita sambung lagi, dia tetap akan infeasible. Jadi jawapan akhir untuk soalan 4D adalah x1 3, x2 0 dan the optimal solution Z adalah 18.
Hi everyone, so I'll continue with question number 5. Question number 5, the problem is to maximize the objective function z equal to 4x1 plus 5x2, where we subject to the following constraints: 3x1 plus 2x2 less than equal to 10, x1 plus 4x2 less than equal to 11, 3x1 plus 3x2 less than equal to 13, x1 and x2 is greater than equal to 0, and x1 and x2 are integer. So our goal is to find integer values of x1 and x2 that maximize z while satisfying all constraints. By solving the question number 5 using Excel solver, we get the optimal solution: x1 equal to 2, x2 equal to 2, and z equal to 18. So I choose to do C programming for question number 5 because C is fast, flexible, and allow us to directly implement brute force or optimization algorithm. So here we use it to systematically test all possible values of x1 and x2 within a reasonable range. So as we can see on the screen, on the slide, on the left hand, where the beginning of the program coding part is we define the variables x1 and x2 and some function to display the objective function and constraint for the output. And then on the right hand, which is the latter part of the code C coding, is our main part of the program where we use two nested loops to iterate through all combinations of x1 and x2 from 0 to 10. For each combination, we check whether all constraints are satisfied. If they are satisfied, we calculate the value of z equal to 4x1 plus 5x2, which is the objective function, and keep track of the combination that gives the highest value. Okay, so this approach guarantees we find the optimal integer solution as long as the feasible region is small enough to test all points. As we can see, the output of the program, which include the objective function, all constraints, and the optimal solution. So in this case, the optimal solution is x1 equal to 2 and x2 equal to 2, and maximum z is equal to 18, which is similar with the Excel solver.
Hi, so now we move on to the next question, that is question sheet, where our objective is to maximize the function z equals to 5x1 plus 6x2 plus 7x3 subjected to two constraints, which is the first one is 9x1 plus 12x2 plus 5x3 less than equals to 40, and the second constraint is 6x1 plus 4x2 plus 5x3 less than equals to 30, and all the variables x1, x2, x3 are integers greater than or equal to 0. So since this is a relatively small problem, we can use a brute force method where we will be trying all possible integers combination of x1, x2, and x3 within a reasonable range. So let's walk through to the code. So you can see here I use 3 for loops to try values of x1, x2 and x3 from 0 to 10. So inside the loops, we check whether the combination satisfies both constraints, and if it does, we calculate the value of the objective function z. So we keep track of the highest value of z found and store the corresponding values of x1, x2 and x3. So you can see a small part of the code where there is a if condition. So this part checks the current value of x1, x2, x3 to satisfy both constraints. So when we run the program, it finds the optimal solution, where from the output you can see that the maximum z is 42, x1, x2 is equals to 0, and x3 equals to 6. That's all from me. Thank you.